Greetings, everyone. Today on our lesson, I've prepared. We're gonna continue with our Pythagoras theorem. The topic and the concept is the measurement. Okay, as I've explained earlier, that when we use a Pythagoras theorem, it's where we calculating the longest side on the right angle triangle, which is opposite to the angle, which is equal to 90 degrees to 90 degrees. Okay, now today we're going to be doing the converse of the Pythagoras theorem. That's where if we know all the length of the length of all the sides on the right angle triangle, then we can distinguish that it's either it's a right angle triangle or not. Okay, as we said that on the right angle triangle, the sum of the two sides, which on the two sides they are equal to the square root of the longest side on the right angle triangle. So that is where that's the converse theorem of Pythagoras theorem, the Pythagoras theorem. And another thing that we should know, we want to the Pythagoras theorem. It also explains the relationship of the sides and the right angle triangle. Okay, so now today we're gonna go through our lesson, and then I'm just gonna go through it quickly. As I've said, we're going to, on our topic today is gonna be the converse of theorem of Pythagoras, then the measurement, and on the CAPS document it's 109. Okay, so I'm just gonna go through. Okay, firstly, today we have just done the corrections of the worksheet that I gave to students on the previous lesson, and we'll be revising. Okay, so on my development now, today we are focusing on the development. Okay, step one. The first thing there is what I've just explained now, but I'm just gonna go through what I've written here for the students. Okay, the theorem of Pythagoras tells us the relationship between the sides of the right angle triangle. As I've just said, we're still just explaining the Pythagoras theorem. Okay, as I've said, if we know the length of the side, we can state whether the triangle is a right angle triangle or not. We call this the converse of the theorem. So it's an opposite. Ne? Now we have the sides. It's just that we have to prove if it's either a right angle triangle or not. Okay, if the sum of the squares on the two sides of the right triangle equals to the square on the third side, the triangle must be a right angle triangle. This is the converse theorem explanation. If the sum of the squares, not just the sum, the squares on the two sides of the triangle equals to the square on the third side, the triangle must be a right angle triangle. Okay, so now I've made an example on my step, another step that you're gonna do here. Okay, this explanation comes from our formula. You remember our formula from the previous video that we said the formula for the Pythagoras theorem is equal to c squared. It's equal to ab squared. Okay, here ab squared plus I've said no, so sorry, I made a mistake. I said c squared is equal to b squared plus a squared. Okay, here's the formula. Now we've just used a different example, but it's the same thing. It's just that now we have that's our hypotenuse, which is AB. Here's our hypotenuse. It's AB. Oh, sorry, it's AC. AC squared is equal to the sum of the two sides, the square root of the two sides, as I've said, which is AB squared plus BC squared. Here's down here. Okay, now we have to prove the converse of the Pythagoras theorem. Okay, the square root, now we substituted here. It's 30 squared, which is the longest side. That's our hypotenuse. 30 squared plus 18 squared, that's AP is equal to 18 squared plus 24 squared, that's our 24 squared. Then we've seen that our hypotenuse is equal to 900. The square root of 30 is 900. And now, as we said, the longest side on the right angle triangle must be equal to the sum of the two squares of the other two sides. As I've said, 18 squared is equal to 224 plus 576. So therefore, if you see, the sum is equal to 900, and the hypotenuse, our hypotenuse is equal to 900. So therefore, APC is a right angle triangle, as we explained at the top there. As we said, if the sum of the squares on the two sides of the triangle is equals to the squares on the third side, the triangle must be a right angle triangle. And another thing, I'll just want to apologize, the weather is bad here. It's the standard outside, but I'll try to do the job. Okay, another thing that I'm gonna do now, I'll be giving a student the worksheet. They will have just to confirm here where we see there. Now we have to just to prove. Now we have to prove, because some of the angles here, they are not the right angle triangle. So now the learners, they'll have to calculate the square roots. For instance, at A, they will have to prove, and therefore they'll have to give a reasoning. It's a right angle triangle or not. So here's the work that they're gonna do. They're gonna take this as, if you can see here, they're gonna take this as the longest side. But now, if you see, even the angle, you see, because now there should be like a T junction here, but you can see it tells you that this is not a right angle triangle. But they'll have to prove it, as I've done at the top, and even here they'll have to do this. And now, but they said here, use the theorem of Pythagoras to find the relationship between the side on each right triangle. State whether the triangle is a right angle triangle or not, as I've stated. So they have to calculate, then at the end give the reasoning. Is it the right angle triangle or not? And then another thing, show that the right angle ACD are both right angle triangle. So now we have combined two triangles here. So now they will have to calculate. If you see, we have this, right, the bigger one, we have this one, it's 8 centimeter, and inside of it we also have another one, which is ACD and ABD. We have two of them. So now they have to prove. But to me, it's obvious. If you can see here, it's a right angle triangle, but they'll have to calculate first, and then on the next lesson we'll be doing the calculations. So this will be the homework of the learners. Okay, on the next lesson, if I had something to write here, we're just gonna write something quickly, just to do one example here and see if the learners can prove that. Okay, I'm just gonna try to write here, just to prove if this thing is a right angle triangle or not. I'm just gonna be quickly. Okay, now we're just gonna do this thing. First, we'll have to substitute our formula. Okay, we'll just do A here first. Okay, we have ACB. Okay, we'll take AC as our longest side. AC squared is equal to another side is gonna be BC squared plus AB squared. Okay, sorry. AB squared. Okay, let's come on. AB squared. B squared. So now we have to substitute AC. AC is gonna be 25 squared. So we should not forget. Oh, my pen now. Okay, It's okay. Just gonna try to find another one. It's gonna be 25, and then we substitute from B there it was BC, it was 24 squared plus, okay, AB it was 7 squared. Oh, I'm having a problem with my pens here now. Okay, let me try another one. Okay, sorry, just a moment, I'm coming back now. Hoping I'm gonna get a better pen now. Okay, we're gonna carry on now with a black pen. Okay, it's gonna be 7 squared. Okay, 25 squared. Let me use a calculator. 25 squared is equal to 625. 625. Now we have to see if the sum of 24 squared plus 7 squared is equal to 25. So 24. Okay, 24 squared it's equal to I know it's 576. Okay, you shouldn't always depend on the calculator. Okay, 7 squared. 7 squared is equal to 49. Okay, now we have to see if the sum is equal to 25. Okay, 576 plus 49, therefore it's 620. 610. It wasn't promising, but you see now it's proving that the side is equal to. Therefore now they have to write the reasoning. Therefore ABC is a right angle triangle. So there's our reasoning. So the learners now have done one example. Now they have to do D on their own and do number 2.